Let's do a simple sum based on similarity of triangles. The sum says that are the triangles ABC and PQ are similar? If they are, we need to justify, right? Now, one thing is very clear that these two triangles, if they are going to be similar, it is going to be by SSS test of similarity, right? Because there is information only about the sides. But for doing that by SSS test, we need to take the ratios of the corresponding sides. But how do we decide for AB which one is the corresponding side? Is it PR? Is it PQ? Is it QR? And are we going to do a trial and error method? No. So there has to be some method. What is that method? Let's understand. It's very simple. What we do is pick up the smallest side in triangle ABC. Which is the smallest side? Yes, it is AC, right? Same way, which is the smallest side here? Here it is QR. That means we know that for AC, the corresponding side is QR, and hence find that ratio. So we'll say here AC upon QR, that is equal to 24 by 16. Both are divisible by 8. So it is 8 3s and 8 2s, and we get this as result number 1. Was that easy? So we have the smallest and smallest. So which is the next one? Very clear, very nice. It is going to be the largest here. And the largest here is BC. What is the largest here? The largest here is PR. That means we are going to take the ratio of these two sides. It is BC upon PR. And BC upon PR is 48 by 32. It is divisible by 16. 16 3s and 16 2s. So the ratio is 3 upon 2, which is our result number 2. Now, let's see the next one. Right, so we have done the first ratio, we have done the second, now do the third. Which is the third one? The remaining one. The remaining here is AB, and the remaining here is nothing but it is PQ. So do that. So it is AB upon PQ, which is 36 by 24. Both are divisible by 12. So it is 12 3s and 12 2s, and that's our result number 3, right? Look here, what do we see? We see from 1, 2 and 3 that all the three ratios are equal. That means we are saying that AB upon PQ, this ratio is equal to BC upon PR, is equal to the third ratio, that is AC upon QR. All the three ratios are equal. We got it from 1, 2 and 3. Now the triangles are similar. Yes, they are similar by SSS test. But how do we write the name of the first triangle? Let's say I take it as ABC. I need to write the name of the next triangle, but it cannot be anyhow. When we write the name of the two triangles which are similar with the similarity symbol, it has to be as per the 1-to-1 correspondence of the vertices. That's very important. Now, how do we decide that 1-to-1 correspondence when it is by SSS test? It's very easy when it comes to AA test of similarity, but slightly different when it comes to SSS test. Not difficult. Let's see. There are two ways of doing it. One way I'll teach you. Observe. What we do is, observe, take one ratio and look at the ratio, numerator. What is that? AB. Now AB belongs to this triangle. In this the three vertices are A, B and C. Now we consider AB. So which is the angle opposite to that? C. We need not see that. Directly we can see, because if AB is there, what is missing is C. Same way in the triangle PQR. PQ is here. So what is missing? It is R, right? So that means for PQ the corresponding side is R, right? The opposite angle is R. So now we can say for C, the corresponding vertex is R. That is what we write here. Easy? Beautiful. Same way, now look at the second ratio. The second ratio again, look here, same way, BC. You're saying BC. For BC, what is the opposite angle? The opposite angle is A. Same way, so now we're talking about angle A, right? So corresponding vertex of A is going to be, let's identify that. Now PR, right? PR is opposite. Angle opposite to PR is nothing but it is Q. So that means we know that A corresponds to Q, and then we write the remaining one. So in triangle PQR, Q is written, R is written. So the empty space is going to be for P. Now we know that both the triangles here, triangle ABC is similar to triangle QPR. Generally you would say it is similar to triangle PQR. No, it's similar to triangle QPR by SSS test of similarity. That is how we do it. So is the correspondence clear how we do it? Now there's one more method of doing it. One more way is going to be very simple. Out of these three ratios, pick up any two. Suppose we pick up this two, first and second. What is common in both? In the numerator, B, right? What is common in the denominator? P. That means B corresponds to P. Check. B corresponds to B, isn't it? Yes. So now here B corresponds to P. What is left? A and Q. So A corresponds to Q. Check. You got it. It's so easy. Pick up any. Let's say if I pick up the second and the third. Okay, we can do it from any two ratios which are equal. Pick up the second and the third. What is common in the numerator? C and C. What is common in the denominator? R. That means C corresponds to R. Check. C corresponds to R, isn't it? Yes. So if C corresponds to R, what is left here? B and P. B corresponds to P. True. And if you get 2, the third one is the remaining one. So there are two different ways. Any one which you feel easy, you can use, and you have to write the correspondence very clearly. That has to be correct, otherwise it goes for a toss. Very important.